Linda knows that when buying equipment for her lab, costs often extend well beyond the purchase price. Therefore, it's important to understand the total cost of ownership of any piece of equipment. Biological safety cabinets, for example, consume electricity, affect ventilation, and require cooling. Within a couple of years, these costs can well exceed the purchase price of the unit. Class 2 BSCs precisely control the balance of inflow and downflow at the front of the cabinet to prevent contaminated air from escaping the cabinet or being introduced to the sample chamber. This is accomplished by electric fans directing airflow through highly efficient H14 HEPA filters. Originally, these fans were powered by AC motors which could operate in contaminated spaces with little maintenance, although they're not particularly energy efficient. The introduction of a modern electronic DC motor can, however, drastically reduce the energy costs of your BSC from 70 to 90%, while providing longer motor life and greater airflow control. At the end of the day, many labs simply turn off their BSCs. However, newer BSCs equipped with intelligent DC motors can enable a night setback mode, whereby containment is maintained with the sash closed and reduced fan speed. The ability to completely close the sash also limits the effects of foot traffic and room air currents when work is left unattended in the hood. Traditionally, BSCs using UV germicidal disinfection were equipped with a simple on-off switch, and at the end of the day, users had to decide between leaving the lamp on overnight, which is both excessive and inefficient, or staying an extra 1 to 3 hours so they could turn it off. Newer models, however, can be equipped with adjustable UV cycle times that can be programmed to shut off at a given time, extending the life of the bulb and protecting materials from unnecessary UV radiation. Contamination is one of the most costly factors in any life science laboratory, resulting not only in discarded reagents and cultures, but loss of the time invested in growing and treating these cultures. Maintaining proper airflow and containment is critical to personal and sample protection. BSCs with high inflow and low downflow risk product contamination, while low inflow and high downflow can put users at risk. BSCs with a dual fan system, each independently controlled, enables the user to achieve precision airflow balance between inflow and downflow. One of the least appreciated factors affecting contamination is ergonomics. Restricted movement is not only uncomfortable, it makes managing samples difficult and can prevent complete decontamination of interior surfaces. Ergonomically designed BSCs should allow for easy access to the interior and have a flat work surface without cracks, bends, or corners capable of harboring contamination. So before you purchase your next BSC, remember to consider the total cost of operation. Technologies such as electronic DC motors can efficiently control airflow balance while enabling features such as night setback mode. Programmable features such as UV disinfection cycles can minimize cost while extending the life of your equipment, and smart airflow compensation along with enhanced ergonomic features can help to prevent contamination, preventing loss of valuable samples and time. Lab Manager. When we talk science, we mean business. Brought to you by Thermo Fisher Scientific.